Welcome back. Today we're going to be evaluating an integral using integration by parts. Just a quick reminder, when do we use integration by parts? We should use it whenever we have an exponential and a trig. That's when we should use it twice, which is what we'll do today for exponential versus trig. We also should use it whenever we have a polynomial by exponential, polynomial by trig, or a logarithmic function. Those are the three other times we would use it. In those examples, though, we would just use this formula, the integration by parts formula, one time. For this, we're going to be using it 2 times. All right, so how would we start this one? Well, the thing is, recall that we want dv, something that's easy to integrate, right? Something easy to go back to v with, and then u to be something easy to take the derivative of, okay? So I'm going to choose sine x for u because of that. So u is equal to sine x, and if u is equal to sine x, that means that du is equal to cosine x dx, right? Because derivative of sine, recall that would just be cosine. Then we're going to have dv equaling e to the power of x. And if dv is equal to e to the power x, that means that v is equal to e to the power x. So I should have put dx there like that. Okay, so now we can apply the integration by parts formula in order to convert this, right? Because essentially here we have u as sine x. So we're going to end up with u here. And then for e to the power x, we get that dv is equal to e to the power x. And so there we go. We have u dv, and so we can plug in all of this. Okay, so for that reason, we now have u times v, which u is sine x. So I'm going to write sine x here. And then we have v, which v we said was e to the power x. And then we had minus the integral of v du. So what was v again? It's e to the power x. And then what is du? Du is cosine x dx. And there we go. There's our first using integration by parts. So now we actually want to apply that same thing, integration by parts again, just to this one. Okay, so ignore all of this. This time I'm going to have my u be equal to cosine of x, which means that du is equal to negative sine x dx, like that. And then I'm going to have dv, same as before. dv is e to the power x, meaning that v is equal to e to the power x as well. And now let's do our subbing. So we're still going to end up with sine x times e to the power x. And then this one here is going to be u times v, which u this time is cosine x. And then times v, which v is e to the power x. And then minus the integral of v times du. So what is v du? Well, v is e to the x, and then du we said was negative sine x dx, like that. Okay, so now we're going to end up with sine x times e to the power x minus cos x times e to the power x. And then let's see, we're going to end up with 3 negatives here, right? We have this negative, and this negative. So overall, 3 negatives does indeed give us a negative. So negative integral e to the power x times sine x dx, like that. Okay, and now we need to actually solve. So recall also that all of this is originally from this one here, right? So all of this is just equal to the integral of e to the power x sine x dx. And we have minus that here. So what does that tell me? Well, that tells me that if we add this to both sides, we would end up with 2 times the integral of e to the x sine x dx is equal to this other stuff. It's equal to, well, if I factor out the e to the x, we get e to the power x sine x minus cosine x, like that. And then if we divide by 2, we're going to get the final answer, right? So the final answer for the integral of e to the x times sine x dx is going to be equal to e to the power x times sine x minus cos x divided by 2 by dividing both sides by 2. And there we go. Now we have solved it. As always, if you do have any questions, feel free to leave those down in the comment section, and we'll see you for the next one.